Hi everyone, I hope you're doing good. My name is Anubhav and I am super excited and glad to welcome you back to my YouTube channel. In the last video lectures, we were going through Dockers and specifically networking in Docker in general. So we built up an application which was called Fortune Cause, where we had two independent containers, and we saw how do we connect these two containers, how networks are created in Docker, what a Docker network bridge is, and all that stuff. We had a pretty good hands-on tutorial in those two video lectures as well. And if you have not seen this, I will link that for you in the description section. Today, however, we are going to look at somewhat more advanced topic, which is deployments in Docker. So as of now, we have built few Docker containers, we have played along with it, we are comfortable with how Docker works, what a Docker container is, what an image is, and all those stuffs. So our base is all covered, but you all know that without deployment, a product means nothing, right? You want the thing that you have made or some project that you have made to showcase it to the outside world. And without it, I mean, no one believes that you have made something. So that is why deployments are very essential in whatever field you choose in computer science. But today we are looking at let's say a more refined aspect to it, which is deploying a Docker container, right? So which essentially means that you have a Docker container and you want to deploy the Docker container into the public web so that like it is accessible to everyone out there. So there is a prerequisite for this video lecture. So you would need a Amazon AWS account, Amazon Web Services account. So for that, you need to sign up to AWS. You need to have a credit card. Yes, there are free tiers available. However, I'm not sure how those free tiers operate, as in like my specific AWS account has run out of free tier because it is more than an year old. But yeah, it does give you some free tiers, so we'll be using EC2 instances, and EC2 has a 1 year free tier, free period where you could use EC2 instances, but you need to be careful on what instance you need to be using. So please be careful around that aspect, and I trust that you would be able to like follow along or get resources which tells you what a free tier is and how to use free tier. However, like for this specific video lecture, I'm not concentrating much on the free tier. For me, like I need to pay anyways because my account is a year old and my free tier has been exhausted. So I'm going to show you how to deploy a specific service using EC2 instance. So yes, there is a prerequisite to this course. Again, repeating that you need to have a AWS account, you need to have a credit card. In case either you don't have a credit card or an AWS account, please feel free to watch along. However, I recommend that you have them both, because then you would be able to experiment and play along with it, right? And once you have that prerequisite, we are all good to go along. So yeah, without much of ado, let's get started. So now we are at the point where we are comfortable in deploying a Docker container. And when you say you want to deploy a Docker container, you mean that you already have a Docker image already present, right? And that is what we'll be deploying onto the web so that it's accessible for everyone to use. So the second prerequisite is that you should already have a running code over which you should have created a Docker image, and more specifically a Docker container. So I already have that in my local PC, and I'll be like going through all the steps with you. But to deploy something to the web, right, and specifically using AWS services, you have three options. Either you could deploy using EC2, either you could deploy using ECS, and the last option is deployment using EKS. So yes, all these three, EC2, ECS and EKS, are different services that are being provided by Amazon. So however, in this lecture we would be focusing more on the EC2 instance because that's the base of all deployment. Even ECS and EKS uses EC2 instances in the backdrop. However, since both ECS and EKS are more of a container orchestration tool and have some aspects of Kubernetes, let's say, in between, right? I'm not going much into that. Obviously we'll be covering that in the next video lectures, but this specific video is all about deploying a Docker container using an EC2 instance. So the first question that should come to your mind is, what is an EC2 instance? So EC2 is a service that is provided by AWS, Amazon Web Services, and think of EC2 as a server, right? As a personal PC or as a personal server, right? So it's a your personal computer somewhere in the cloud. Obviously, like, you do not know where that is, like, because there are different data centers of AWS out there, but it's present somewhere, and that is an instance or a server that you could always play with. So just think it of as your personal PC somewhere in the cloud, and you might be deploying all these projects on your local host as of now, right? Like, you create a, let's say, a Flash server, you deploy it, correct? And because that's local host, that's only visible to you, cannot share that. But think of EC2 as a machine, or as your personal computer somewhere inside, somewhere over the AWS servers, right, where you can always go to deploy a specific thing. And because that's a publicly accessible machine, or rather you would get some publicly accessible IPs that is visible to the entire world, right? And that is what EC2 is all about. So just think of EC2 as your personal server, or you can also say your personal computer. Anything that you can do on your personal computer would also be feasible, like that could also be done using an EC2 instance, right? So once we go to the EC2 instance or the EC2 dashboard in AWS, things will become much more clearer as and when we go to the options. So you can select your own operating system, you can select what amount of memory do you require, what amount of RAM do you require, and all that stuff, right? Like the same thing that you do while you select a personal computer or a personal server of your choice. So we would be looking at deploying a Docker container using an EC2 instance. Yes, EC2 has a full form. I think it's called Elastic Compute Cloud, and that is why C2 refers to compute cloud, but not very much important for us to know. So yeah, I want to make this tutorial much more hands-on, so I hope you will be able to follow along. I'm not going to deep too much into the theory. I'd be showcasing you how to do that, and then that's how we'll be closing this chapter out. So yes, I hope you all are excited to follow along. So without much of ado, let's get started. I will move on to my IDE. So over here you can see, like, I already have a Python code, or let's say a Flask code already written. So this is a very simple website that I have made. What it does is, like, it takes a GitHub key, right? Like, it takes a GitHub key as an input, and then it auto commits every day to your GitHub account. So it creates a random repository, and it will be auto like committing to that specific repository, a random specific thing every day. That is what it does. You don't need to know, like, how the code has been written and all that stuff. That's not what we are into. What we are more focused on, or what we are more interested in knowing, is how to deploy the containers to, or a Docker image to, a EC2 instance, right? But yeah, just to let you know how this website looks like, what I will do is I will just run this first on my local machine, like a local Flask server, right? And then I will show you how the thing operates, right? So I will just write python 3 app.py, right? And as you can see, this is up and running on localhost 3009. So I will go back to my Chrome, and I will do localhost 3009, right? And yes, this is how the website looks like. It's a very simple Flask code with two APIs out there. The first one takes in your, like, GitHub key as an input, right? And once you press on lazy, let's be lazy, it will, like, store the specific information onto a RDS, or let's say a MySQL database, where, like, it will have your username, your GitHub username, your token, and till which date, on which date the specific thing was done, and till which date, like, you want to be active. So I follow a 7 days period where, like, it will create a repository for the first time, and then commit to that repository a random commit every 7 days. But again, you don't need to know that. What I'm more interested in that is creating a Docker image for the specific website, right? And deploying this onto the EC2 instance. Correct. So yeah, this is what I'm more interested in. And as you can see right now, this is running on localhost 3009, and you cannot share this specific thing. So someone says, okay, this is a very interesting project that you have made, but could you share this so that I can view this? Obviously you cannot share localhost 3009, because that won't work for them. So either you would share the code, or you would share the Docker image, correct? And the best way is, like, you could always share them a specific link where they can always view this specific website that has been hosted. And we are more interested in the later part, obviously. So yeah, the answer to this is creating a Docker image, and then we need to upload that Docker image to the Docker Hub, right? We will then set up an EC2 instance. We will go through all the configurations. We'll pull that Docker image from the Docker Hub, and then specifically see if we are able to access this website or not. So yeah, pretty interesting things out ahead. So follow along. If you have any doubts, feel free to shoot in the comment section. Let me clear this output once. So the first thing for any code that you need to Dockerize is to write a Docker file, right? And that's why I'll be proceeding writing a Docker file for the specific code as well. So I would just name this as Docker file because that's what you're supposed to name it. And this is a Python based, like this is a Python code, right? So I would obviously need to pull in the Python image. So I will write from Python dash 3.9. It should be like Python 3.9. It's slim, yeah. So I would need to pull in the Python 3.9 image, which will be going to be a slim image, right? So this line specifically says what code or like what programming language do you want to specifically fetch in, and I need to fetch in the Python 3.9 image, right? And that is why this is like this. Then I will proceed to create a working directory which I will name as app. So work dir followed by /app, right? And once you have this, so a Python code or a Python project will always have this file called requirements.txt. Obviously as of now I do not have this specific file. I will, after writing this Docker file, I will go ahead and write the requirements.txt file. But I hope you're aware of the fact that a Python project will always have a requirements.txt file which lists out all the libraries that are required in this specific code to be executed. So what happens is, like, this requirement.txt file is there in our Python code, and then we run a command which says pip install -r requirement.txt. So it goes to that txt file, it reads that requirements.txt file and installs the list of all the libraries. So the first step that we would need to do that, or the third step rather than our Docker file, would be copying this requirements.txt file. And when I say copy requirements.txt file, it means copying the requirements.txt file from your desktop or from your host machine to your directory, which is /app, which you can always say with or which you can always replace with a dot, because you're always in that working directory as of now. So I will just write copy requirements dot txt followed by a dot. So what it will do is it will pick up the requirements.txt file from our code, or like from the specific directory, and copy this to the directory which is /app, right? And once you have this, as I told you, the next command that you will need to run is like running pip install -r requirements.txt, so that all the libraries are installed. So I will just run pip install -r requirements.txt, correct? Once you have this, you have set up your base or your Python project, right? So you have already fetched in the Python image, you have created a working directory, you have copied the requirements.txt file, and now you have all the list of libraries that is required to run this specific project. And why this is important, because I will again reiterate on this fact that EC2 is like your personal machine or your personal servers or your personal computers, right? So it does not know what Python is, what libraries you require. So while you were first setting up your project on your host machine, you were required to install Python, you were required to install all those libraries. But because I've already done that, you skip that specific matter, or you are not interested because you know, okay, these are already installed on my system, so I won't be running into the problem of this library does not exist. But because EC2 is a fresh instance on the cloud, not being used, it does not know what Python is, and once you install Python, it does not know, okay, I also require XYZ libraries. You need to specify all these in requirements.txt file, and then like install the specific libraries out there. So this is what the job of line number 3 and 4 is. So once that is done, I will copy all my remaining files. So I will write copy ... which means copy all the remaining files from this present directory to the app directory that we have already made. And once that is done, now what I need to do is I need to expose my port. So if you go back to my app.py, you will see that my app is running on this specific port called 3009. So now, like, once you create a Docker container, or like, because Docker containers are isolated, so you would need to see what port you would need to expose, so that there can be a connection that be made from your host machines to your Docker containers. When we run the Docker run command, you might have seen the option of -p, where we give the port numbers. We say this port should be the specific port on my left hand side on my host machine should be mapped with this specific port on my Docker. So obviously you need to expose a specific port, and for me that is 3009. So what I would write is, I would write expose port 3009, not port but expose 3009, so expose 3009. And then the last step would be the cmd command, which says how would this application start. So obviously it's python, python 3 or python over here, because it does not has a python 2. Your ec2 instance would not have a python 2 version. We would be like, it's a by default python 3 version that would be running. So python app.py. So this is your docker file. Correct. I hope you are comfortable with the syntax of docker file. It's very easy. You just need to follow certain steps. You need to keep in mind that because let's say docker container is an isolated environment. It does not know what python is, what the libraries that are required to be used is. It's a fresh environment out there, so you need to say all the specific step. You need to tell them what specific steps it needs to follow. You need to say that, okay, you need to pull in a python image, then you need to install all these required libraries. Once you have installed all the required libraries, I can now copy all my remaining files. I can then expose a specific port, and then I can finally run that. And then and that's the beauty of docker, right? Because once you say once you create a docker image, all these instructions are automatically stored, and you can now pick up this docker image, go to any fresh instance, which in our case is an ec2 instance or an ec2 server, say that, okay, this is my docker image, and now docker does all the stuff for you. And that's the beauty of docker, and that's why you are able to use docker in such an efficient manner. So yeah, I hope this docker file is all good. What we are remaining is creating a requirements.txt file. So I will just go ahead and create the requirements.txt file quickly as well. I will name it as requirements.txt, and I will show you what libraries do I require in this specific piece of code. So some of the libraries will already be installed once you install python, because those are system specific libraries, but there are some that you would obviously need to install. So the first one is you would need to install explicitly, I should rather say. The first one is Flask, because Flask is not by default installed by python. You need to install Flask explicitly. So the first one is going to be Flask. The second one is going to be your request library. Request is the library that you use to interact with make requests, right? As in, if I tell you, let's say you need to make a API call to any of the servers, let's say amazon.com/this product, right? You need to make a get call. How do you do that in python? You do that with the help of a request. Request gives you or exposes the specific methods to make a post call, get call, and all that stuff. So yeah, this is on the request library. This is the second library that we need to install. The third one, if you see, is this MySQL connector. So this is a specific library again, which will need an explicit handling or installing. So I will see what this library is called. So I can call MySQL connector pip. So this is called MySQL connector Python. So I will just copy this. You can also think of request as, if you work in Java, it's more of your synonymous to your rest assured, right? How you make API calls. So yeah, request is like this, and MySQL connector Python is more of let's say I want to connect with a database using Python, right? How do I do that? I do that with the help of this library called MySQL Python. I think the rest of the libraries are already by default installed with Python. Once you install Python, all these libraries itself come, JSON being one of them, OS being another of them, logging, datetime, yes. Crypto does not come with Python, so yeah, I would explicitly need to install cryptography as well. So the name of this is called cryptography. So I will just write cryptography, CRYP, cryptography. So yeah, these are the 4 libraries that would need my installing, that would need an explicit installation. Do I need any other of it? No, I think that's all good. So with that being said, we are all good to create a Docker image. And once I've created a Docker image, I will showcase you if I will run a container, right? And post that container, what I will do is I will see if I'm able to access that specific website using my container or not. So that would give us much more confidence that, okay, our Docker thing is itself set up. We can always go back. We can always go ahead and do the stuff on EC2 then. So yeah. What I will do is I will first delete all the images and the container so that you are not confused. So yeah, I will delete this, delete this, delete this, delete this as well. Containers, okay, like take it, let me delete this as well. So yeah, let me build a Docker image first. So I will say Docker build -t followed by the name of the specific image, which I will say it's git auto commit, followed by tag name, which is v1, followed by dot. So this would build this specific image for me. So let me build this image, and it will take around 10 seconds to build this specific image. So let's wait till that. And as you can see, it's running the required libraries and all that stuff. So yeah, taking a bit more time than expected, but should be done soon. So yeah, it took us around 12 seconds, 14 seconds to build this specific image. And now this image should be shown on your Docker desktop as well. So yeah, it's called git auto commit. This image is unused, and this is a 326 MB image. So yeah, much more, but all good. So now what I can do is I can always run this specific I can always run a Docker container and see like if things are working fine or not. So I can run Docker run. I want to run it in -detached mode, or that's why I will have a flag called -d followed by a port which is 3009, followed by 3009. The name of this container would be git auto commit container, followed by the name of this image, which is git auto commit, followed by v1. So yeah, this should be working fine. Let me see if it's the case or not. So it tells me there is a container has been created with this specific id. I can always go back to my Docker desktop and see if this container is all good or not. So as you can see, this container is up and running. What I can do is I can now go to my Chrome and type localhost 3009, and as you can see, like, yep, things are working fine as of now. So all good till over here, correct? So if you have followed along till this point in time, pat your back, because I know this has been quite a ride. But yeah, we have not done anything special as of now. What we have done is like we just had a code, let's say a Python Flask application. We created a Docker file out of it. We built a Docker image, and we saw like we use a Docker image to build up a container, and so if things are working fine or not. Meanwhile, I will go ahead and close this container because I do not need this. Now, this is where things get much more interesting. The reason being, now we have all the things that are required. Like we have a Docker image, but we will now need to deploy to the public, to the outside world, which means on an EC2 instance. And for this, your image should not be on your local Docker desktop, because if it's in your Docker desktop, like no one would be able to pull that image. So if you have seen, like let's say if you do Docker run MySQL, right, it first searches on your local desktop or on a local system. If it cannot, it then pulls that up from the website or from the Docker hub. Correct. So which essentially means that why you deploy, because your EC2 instance, you will be deploying this specific code in your EC2 instance. Your EC2 instance does not know, okay, there exists an image of this specific git auto commit somewhere in, let's say, Anubhav system. Or if it also knows, it cannot connect with that. So which essentially means that you would need to take this image and you would need to put it out somewhere, make it publicly accessible, so that every system, whether it's an EC2 instance, whether it's my system, which means Anubhav systems, or which also means it's like XYZ systems, they should be able to pull in this specific image. So that is why I would be storing this image in something called Docker Hub. So Docker Hub, you can assume it as a registry or repository of all the Docker images. So just it's very similar to your GitHub. So in GitHub, you store all your code. In Docker Hub, you would store all your Docker images, so that it's accessible to everyone. So again, as your GitHub, like your GitHub has public and private repositories, Docker Hub also has public and private repositories, which means you can either make your images public or you can also make your images private as well. But to simplify things, what I'll be doing is I will be using a public image, or I will be making this image as public. So for that, obviously, you would need access to Docker Hub. So I will first go to Docker Hub right? It should be not ton, it should be hub, but anyways, does not matter. The first link over here, you would be asked to sign in. I think I'm already signed in, so it would not ask me, but okay, let me just sign out first so that I can show you all the steps. So yeah, when you click on Docker Hub, the interface would be something like this, obviously depending upon when you see this video, but as of the date of January 12th, this is how it looks, January 12th, 2025. This is how it looks. So you can always click on sign in. Once you click on sign in, you can click on sign in back. It tells you to enter your Docker password, so I think I should continue with Google instead. So yeah, I'm logged in now, and now what you need to do is you need to create a new repository. So I will say the repository name is git auto commit, and this is where you will be storing your image. It tells me to it asks me to write a short description. So the short description is a git auto commit image. Yeah, just a random description. You don't need to think much on it. And see, you could also see some specific commands that you would be required in future. So yeah, it would, like, we would need this in just next few minutes, but coming back to the basics, like, it tells to create a repository, it tells you to give a name to the specific repository, it asks you to give the name to the specific repository, same as what you do in GitHub, and tells you what should be the visibility of this repository be. So either it should be a public one or should be a private one. Public one means, like, anyone, like, once you publish the image, anyone would be able to pull in this image. Private means obviously like only people with authorization, or you would need some keys in order to like pull that image. But to make matter simplified, I would be using this as a public image. So I will just create on or I will just click on the visibility as public and then create. So this specific repository will start getting created, and once that is created, you will see, like, you will have something called tags and builds. And I think now you should be able to relate it more to Docker, because Docker works on images. Images are also tagged, so this is what a tag specifically is. So yeah, once we have created this specific repository, now we should be able to push images to this repository, right? And then, like, when required, we would also be able to pull in images from the specific repository. But I think you forgot the steps, what is required to be done. As in, like, if you were following along at this point in time, you will always see like this specific command appearing in. So it first tells me that I need to tag in my local image, right, to the specific repo name and the image, and then push the specific image to Docker Hub. So yeah, let's do these steps. But before that, I would first do Docker login, because I would need to push this image to Docker Hub, which essentially means Docker Hub needs to be authorized or authenticated to push this specific image, and hence to do a Docker login so that the communication between my terminal and Docker Hub be established. And as you can see, it tells me login has succeeded, which is a good news for us. But now we will again go back to Chrome and see the commands. So the first command is tagging the image. So, or essentially it means is tagging the local image to the specific repository name that you have given, right? So if you go back, my repository name is git auto commit. So what I'll be doing is I will go back to my terminal. I will say docker tag git auto commit v1. This is my local image, and if you want to reconfirm, you can always go to your Docker desktop, see what the name of the image is and the tag is, which is called git auto commit followed by a tag of v1. So docker tag git auto commit followed by the repository name on which you want to tag, over which you want to tag. So the repository name is Anubhav83 git auto commit followed by v1. So yeah, this is my local image name, and this is my repository name, which is Anubhav83 git auto commit v1. And always confirm your repository name by going to your Docker Hub. So Anubhav83 git auto commit, and I want to give it the tag of v1, so I've already specified that. So yeah, it's just a tagging. And once you have tagged, you can write docker push docker push Anubhav83 / git auto commit followed by v1. Correct? If I do this, it should now push the image to my Docker Hub. So yeah, it will take around a minute or so to push this specific image, but till then I hope like everything is clear on this video. I know it's been a long video, you need to follow a lot, but I hope your time has been better utilized learning all the important Docker commands, building a Docker image, following up with a container, then like going to Docker Hub, doing the login, tagging the image, and then finally pushing it. And as you can see, like this specific image has been pushed to your Docker Hub. If you want to confirm, you can go to this repository, go to tags, and you should see the tag appearing over here, and it says this is a Linux ARM64 V8 image. So yeah, as of now, mine but the image that I wanted to push, or that I would be essentially pulling it in my EC2 instances, is now deployed on Docker Hub, which means that I should now be able to pull in the image as and when required. And because the video is getting a bit long, I think we have already been around the 30 minutes mark. What I should rather do is close this video out here, because otherwise it would be too long. We can move on to the next video, where I will show you how to spawn up an EC2 instance, what configurations do we need to pick, then we'll be installing Docker on that specific EC2 instance, because as I told you, EC2 instance is a fresh machine, right? So it does not know what Docker is, what Python is, all those stuff. So we will first need to install Docker. Once Docker is installed, we'll be pulling this Docker image and then running it and see if it works or not. And once, because EC2 machine would be a publicly accessible machine, I can just then share that IP address or your web page address, and then it should be accessible to everyone out there. So yeah, this is what we'll be doing in the next tutorial, but I hope you enjoyed this one. In case you have any doubts, feel free to comment, and I would request you to subscribe and follow for more. Thank you. I hope you have a good day. Bye bye.